Lenz's law. The Faraday's law of induction gives the magnitude of the induced EMF. But what about the polarity of the EMF? The polarity of the induced EMF is given by a law of electromagnetism called Lenz's law. Let's take the Faraday's experimental setup once again. This time we replace the galvanometer with a light bulb and the coil connected to the battery with a bar magnet. Once again, we move the magnet into the coil at a constant velocity, say v. As long as there is a relative motion between the two, the bulb lights up. Now, the question is, where does the bulb get the energy to light up? It is from the work we do to move the magnet into the coil at a constant velocity. When we move the magnet towards the coil, we experience a repulsive force from the coil that tries to slow us down. So, we must do some work to overcome this force and move the magnet towards the coil. Now, we replace the light bulb with a new one of higher wattage and repeat the experiment. To light up the bulb, we need to move the magnet into the coil at the same velocity v. But this time, since the light bulb is of higher wattage, it requires more energy. So, we have to do more work to move the magnet. How does this happen? As we try to move the magnet into the coil, we experience a greater force that tries to slow down the motion of the magnet. This is much like moving the north pole of a magnet towards the north pole of another magnet. Thus, the coil behaves like a magnet such that it will oppose the motion. For a coil of wire to become a magnet, current must flow through it. The direction of this induced current must produce a magnetic field that will oppose the change that produced it. This is Lenz's law.